All right, here's example 2, another airplane problem. These are kind of tricky, and a lot of it has to do with the sketch, so we got to be careful how we set these up. Um, and the vectors that we include on those are semi to scale. That usually helps quite a bit. So here we go. It says a pilot wants to fly on a bearing of 74.9 degrees. By flying due east, he finds that a 42 mile an hour wind blowing from the south puts him on course. Find the airspeed and the ground speed this time. So I'm going to start with the wind vector here. I think it says we have a blowing from the south, 42 mile an hour wind puts him on his course. So let's say, hey, this would be represent 42. There's our wind speed vector. And again, our plane is just right here at the bottom of our due north line. There's our plane for the time being. The vector 42 is going to represent the wind speed. So we can go ahead, we'll get that drawn in there and labeled. So this vector, that's going to be wind speed, and we know the magnitude of that is 42 miles per hour. Okay, so there's that one. Second one says a pilot wants to fly on a bearing of 74.9 degrees. So 74.9 degrees, you know, if we're thinking there's maybe somewhere into about that direction there. And again, we would assume that its magnitude is bigger than 42, so we'll stretch that out a bit. But that is one of the things we need to find. So we'll call that ground speed. That's where he wants to go. And again, we don't know its magnitude yet, but we should be able to find it. And then also it says by flying due east, he finds that a 42 mile an hour wind. So the plane, his airspeed, he is flying 42, some miles per hour due east, which would be straight right, which is kind of going to give us one of our angles here too. So we know then that the airspeed is actually a 90-degree angle because we're flying due east. All right? Now the tail to tip idea here, we should be able to take our ground speed, or produce our ground speed, because that is the resultant of airspeed and wind speed. So that one was just off by just a touch there according to our lengths. But there's our setup. Again, due north line, and the wind speed is also a due north line here because it's blowing from the south. We know that's a 90-degree angle. Alternate interiors would say that this is a 90-degree angle down here if we stretch this out, which means this also is a 90-degree angle. All right, so the wind speed here at 42 miles per hour is enough then for us to go ahead and pretty much find both ground speed and airspeed. And actually all we're going to need is SOHCAHTOA here because we did make this right triangle and or the Pythagorean theorem. So if we take a look at solving this thing through, the one thing we don't have is an angle other than the 90 and this one here. We know that this angle is 74.9 degrees, which if you think about alternate interior angles again, that would mean this being a transversal, north-south lines here, north-south lines being parallel, this would be an alternate interior. So this angle is also 74.9 degrees, which we could use that angle with this side, or we could actually use our triangle sum formula. You know, all three angles add up to 180 to get this angle, and then go ahead and find ground speed and airspeed. We'll just use the given values here. So from our 74.9 degree angle, if I want to find airspeed, that would be opposite over adjacent, the 42 degree side. Opposite and adjacent sounds a lot like tangent. So if we go tangent of 74.9, that should be equal to the magnitude of airspeed over 42. Multiply both sides by 42. And that should give us our airspeed vector. So let's plug that in quick. 42 times the tangent of 74.9. Hit it. There we go. So our airspeed vector is going to have a magnitude of 155.67 miles per hour. Okay. Now ground speed vector, we'll use the same given information there, but this one we want to know hypotenuse, and we know adjacent from our 74.9 degree angle, which sounds like cosine. So cosine of 74.9 degrees is equal to adjacent is 42 over hypotenuse is our ground speed unknown vector. So in this case, we got to multiply both sides by magnitude of g, and then or do some cross multiplying here with our ratios. So we'll get 42 equals magnitude of G times cosine of 74.9 degrees. But if you simplify that, just divide both sides now by cosine. We get 42 over the cosine of 74.9 equals magnitude of G. All right, and plugging that in, let's take 42, divide by cosine 74.9, hit enter. There's the magnitude of our ground speed vector. 161.23 miles per hour. And there we go. Found both of them. Hope that helps. If you could take a crack at some of the example problems, see if you can figure them out. Ask questions, please. This is not an easy setup for any of these problems by any means, but get the help you need. So good luck.